Alrighty, welcome back. All right, right now we are talking about Aroc, average rate of change. Average rate of change. The first thing we need to remember about average rate of change is this super fancy equation that will be on the board for you when you retake this test. Remember, the equation is m equals y2 minus y1 over x2 minus x1. Okay, because we've got two y values and we've got two x values, we're going to need two coordinate points. Remember, each coordinate point has an x value and a y value. Okay, so I know since I've got y1 and x1, well, those are probably going to go here. My first x value and my first y value, excuse me. Let me try that again. My first x value and my first y value are going to go right here in my first coordinate point. And then we've got x2 and y2. Those are going to go in my second coordinate point. So they're going to go right here, x2, y2. And remember, those 2's just mean this is the second coordinate point. They don't tell you to do any math or anything. They just tell you what coordinate point you're in. These are 1's because they're saying we're in the first coordinate point. These are 2's because they're just saying we're in the second coordinate point. That's it. They don't tell you to do any math or anything. They're just telling you where to look for the information you need. Okay, back to the problem. I want to find the average rate of change on the interval of x equals -1 and 1. Okay, let's find where x equals -1 and where x equals 1. Here's my x-axis. Here is where x equals 1. You know, I'm going to draw a slice where x equals 1. Let's draw just a chop. Slice. Okay, and so we took care of where x is 1. Let's now find where x is -1. Again, here's my x-axis. Here's where x is -1. Let's draw another slice there. Chop. All right. So now we have set up the interval of where x is -1 to 1. Basically, this is kind of nice because now we get to ignore the rest of the graph. I don't care about it. All I care about is what's happening in here. All I care about is what's happening inside this little tiny sliver of the graph. Oh, there's the bell. All right. So in this tiny sliver of the graph, if I keep zooming in, the only part of the line that we started with that's inside this tiny sliver is right here. What I want to know is, what's the coordinate point where the slices crash into our original line? Or in other words, where does our original line cross the interval, the two slices we made? It looks like one of them crosses right here. And one of them crosses right here. Okay, let's figure out what those coordinate points are. It looks like for this one right here, our coordinate point is going to be, let's see, it goes, remember, x comma y. So it's going to be, okay, well, how far to the left did I go? I went left 1, so I'm going to have -1, comma. And then how far down did I go? It looks like I went down 9, so I'm going to say -9. Okay, not too bad so far. Okay, if I look over here, okay, remember it goes x comma y. Okay, well, how far to the right did I go? I went right 1, so I'm going to have a +1. And then how far down did I go? Well, I went down 9, so I'm going to say -9 there. Hey, it looks like here we've got two coordinate points. That's what we need to fill in this equation right here. We need two coordinate points. So I'm just going to fill in the values. I'm taking this guy, putting it in right there, and I'm taking this guy and putting them all in right there. Alrighty, so for my first coordinate point here, I had -1, comma, -9. So I'm going to write -1, comma, -9. For my second coordinate point, I'm putting it in right there. In that coordinate point, it looks like I had 1, comma, -9. So I'm going to put in 1, comma, -9. Okay, well, now we have everything that we need. If I go through and I label this coordinate point, because it's my first coordinate point, I can call this x1, And because this is my first y value, I can call this y1. Once again, the only reason I have these subscripts, is what they're called, those tiny little numbers at the bottom, is just to say, hey, this x, it belongs in the first coordinate point. This y, it belongs in the first coordinate point. That's it. That's all they mean. They aren't telling you to do any funky math or anything. And then if I come down to my second coordinate point right here, because this is my second x value, I can call this x2. Because this is my second y value, I can call this y2. Again, it's not asking you to do any math here. All this is saying is this x value, it goes in the second coordinate point. This y value, it goes in the second coordinate point. That's all it's saying. No math or anything. All right. Next step, all we're going to do, y2. Oh, well, I know what y2 is. It's -9. So let's just fill in the values that we need here. So I'm going to say, okay, y2 I know is -9. Oops, that was a mistake. Here we go. Minus, it looks like the next thing I need is y1. Okay, so y1 I know is, -9. Okay, so I'm going to put in minus -9. Be really, really careful here. This is a spot where a lot of kids mess up. Just because there's a minus sign there doesn't mean you don't need the negative sign in front of the 9. All right, well, that takes care of the top. Let's now do the bottom. Okay, it looks like the first thing we need is x2. Oh, thank goodness, I know what x2 is. It's a 1. Okay, minus whatever x1 is, right? Minus x1, so I'm going to go right here. Oh, x1 is a -1. Once again, I'm being really careful. Just because there's a minus sign there already doesn't mean I don't need to put in a negative sign. Negative times a negative equals a positive, which means that minus negative becomes a plus. Perfect. All right. So this is then going to equal, let me switch back to red here. Here we go. Okay, this is going to equal -9 plus 9. Well, even if I type that into a calculator or if you just do it in your head, that is going to equal 0. Divided by or over 1 plus 1. I hope you guys can figure that one out. That's going to be a 2. Now, if you type in, or if you just know, type 0 divided by 2 into a calculator, you're going to get 0. Now, if we look again right here in our picture, the slope, the average rate of change, right here inside the interval, is a flat line. When the slope is 0, that means it's a flat line. Alrighty, I hope that helped. If it didn't, sorry, that's the bell. Okay, I hope that helped. If it didn't, come and see me. This is one of the most challenging things on this test, so there's no shame in asking for help on this part. Well, or any of the parts. Anyway, just come ask for help. Nice to talk to you guys. Goodbye.